All right. Hi, everyone. Welcome. Thank you for coming. Thank you, NDC Porto, for having me here. My name is Pablo, and I'm going to be talking about a little bit on security. So let's get started. A little bit about me. I'm a developer relations engineer at SysDig. We do cloud security. And I've been 15 years with open source. I love conferences. I like organizing them as well. I've been a developer, been a DevOps, been a little bit of a bunch of things. Nowadays, education is my passion, so I spend most of my time creating trainings, creating content, basically helping engineers, helping developers succeed in what they are doing. A little bit about you. So hands up if you use containers. Okay. If you use Kubernetes, not so many. You consider yourself a developer. Yeah. You consider yourself a DevOps or Ops person. Security? Okay, very few of you. Yeah, originally the talk, it's very targeted to security, but because of the audience, I kind of shift a little bit in talking on the supply chain and more focus on developers, so I guess I did it right. Anyone here know what eBPF is? Cool. And Falco. All right, you're going to talk later. Great. So now about this talk. So I'm going to start talking a bit on the cloud security landscape, how we see it, what's happening, what are people talking about. Then I'm going to go into the software supply chain, what are the attack vectors, what can you do and pay attention to, mention some attacks that happened in the past and what we can learn from them. Then I'm going to go into some practical tips. Finally, I'm going to talk about runtime security, maybe not so interesting to all of you, but that's kind of where I spend most of my time. And I think it's pretty cool to show off an attack like Log4Shell just happening on the fly, especially because the bug, the vulnerability, actually happens within the code. So it's on your side as well. And finally, we do some closing remarks. So starting with cloud security. Once upon a time, there was a perimeter, right? We could think about the application being within a castle, within the data center, and all we need to care about was basically a bridge that people would use to get into your network, get into your system. So basically, securing the bridge or securing the perimeter was all that you need to do. But things have changed. Cloud emerged, microservices are there. And we can think about things nowadays more about a wonder park, right? You have a lot of services all over. You have things communicating with each other. And now you don't want to stop. You don't want to block a service from accessing another one. You want things to be moving around. Networks are very dynamic. So you need to be paying attention to what's happening without really blocking, without interrupting a service, because that costs a lot of money. So this is the anatomy of a cloud application from a high-level overview. You have the data layer all the way there. This is going to be your database or your object storage like an S3. Then you have your workload. That's the bread and butter. That's your application. That's running what you really care about. It could be running on an instance, in a container, serverless, doesn't really matter. You have the identity and access part, basically who or what has access to what. And here, who could be a person, but can also be a service. Actually, most of the identities that we currently have in clouds, they are services. They are not humans, right? And we want to make sure that they only have access to what they need to have access to. Finally, you have management with messaging services, logs and monitoring. You have the platform that can be provided, Kubernetes, containers as a service. And you have the network part with audit logs. You have load balancers and the groups. You have the cloud infrastructure, and you have the cloud provider. And in this case, I'm putting some public, but you could also be thinking in a very similar way about a private cloud, not necessarily a public one. Okay? So since we have all this, everything becomes an attack vector. From the attacker perspective, everything is an option. It's something they're going to try to find a bridge into your system because of that. So some main cloud attack vectors that we have nowadays basically are the cloud network, right? Attackers, they would try to get into your network, and from there, they're going to try to move within your network into other systems, into where the sensitive data is or where important stuff is. Unauthorized resource access, so within the network, what can it do next? And one of the things it can do is basically try to find sensitive data. And in many cases, people would just leave this data out there without any extra protection because they think that the network is already secure because it's in a private network or something like that. And that's not the case. Or even worse, they might be just left some credentials lingering in the image that they were working on before they actually published that. And by the time the attacker gets into the container, they try to find a key or some credential, and they just keep poking and moving around. Cloud data exfiltration, since I got access to this data, I'm going to start pulling this data out of there, and then I'm going to leak, I'm going to do some ransomware. There are so many options that attackers can go with. Cloud security misconfiguration, so you have the control plane, you have identities. There are a lot of different pieces in the puzzle, right? And you need to pay attention to all of them. And finally, vulnerability exploits. I mentioned Log4Shell with Log4j vulnerabilities, but there are so many more out there, right? From Apache to Node.js to basically any piece of software that we have. It's going to have a vulnerability sooner or later. Good. So let's talk about CNAPP. That's kind of the first acronym that I want to bring to you. So CNAPP stands for Cloud Native Application Protection Platform. And not so long ago, it became this kind of a group of different things within the cloud systems. So one of those things is CSPM. That's Cloud Security Posture Management. Here we are talking about basically configuration. S3 buckets, are they all private? Not sure if you know, but in the past, S3 buckets, they were not private by default. That's when a lot of different leaks happened. People would just put data within S3, they would not know that it was public, and then attackers would just get access into that. Infrastructure as code. As you provide your infrastructure and you do that with code, like, is it set up in a correct way? Cloud inventory, are you compliant? So this is about your posture management. Here's some facts like FlexBooker, 3.7 million users data leaked, Pegasus Airlines with 23 million files leaked as well. We're talking about Civicon with 100K files of audios and videos. This is very sensitive data. With the Pegasus Airlines, you had like the flight trackers, you had like the crew data with passports, a lot of sensitive data in there. All that because misconfigured S3 buckets or just a misconfigured policy within the cloud. Next one, we go to CIEM. That's the Cloud Infrastructure Entitlement Management. That's about identity and access. The important part here is nowadays we have a lot of users configured. We have a lot of services configured to access other services. And we need to do that thinking about list privilege. Yeah, it is tedious to make sure that you only have access to what you need, and at some point, if you need more access, you need to go through a process of asking for the access, waiting a little bit, and that's usually not the best flow, but it is really important. A lot of attacks actually happen because identities have more access than they had to have. Here are some data. So 90% of granted permissions are actually not used. And a very interesting one, in my opinion, is actually 58% of identities, they're non-human, right? So those are services accessing other services. And out of those 58%, 98% of them actually have permissions that have not been used in the last 90 days. So that definitely shows how we are doing over permissioning here, and that's actually a big, big problem. So going to the next one, CWPP, that's the Cloud Workload Protection Platform. Here we are talking about image scanning, we are talking about vulnerability management, CI/CD pipelines being secure. 87% of container images, they actually have a high or a critical vulnerability. That's not a big problem on itself. Many of those vulnerabilities, they are actually not exploitable. So what's really important, and that's more within the security team, that you filter this down into actually what matters. So you can focus either within the security team or the ops team or just talking to the developers. Out of those 100, which ones actually have a patch available that we can use, which ones are actually used at runtime, so the libraries are actually being loaded and the vulnerability is actually loaded into memory, and which one of those at the end of the day are actually exploitable, right? So only 2%. If you have the tools to actually narrow it down, you're basically going to be way more efficient. Great. So to the last one, CDR. This is cloud detection and response. This is the last line of defense after you have put all the other things in place, after you have worked within your security. Like securities are always come in layers. How do you do your threat detection? How you make sure that your system has not been breached? And that suspicious activities are actually being brought to your attention, right? Containers, Kubernetes, doesn't really matter. We are talking about runtime security within this scope. So companies, they take about 207 days to identify a breach. Attackers, they are getting more and more clever over time. And one of the things they do is by the time they get into your system, they just lay low. They don't start doing a lot of fuss because they got access to it, right? So they just take their time. They go little by little, just waiting for another breach, for another error, for another misconfiguration. And they're just in there collecting this data, collecting this information. And after companies have actually identified the breach, they take another 70 days to contain it. We're talking about 9 months between an attacker getting into your environment somehow and you actually being able to say, okay, we fixed the problem here. And the average cost of a data breach, it's basically $4 million. That's what the estimate is. Good. So all those different acronyms, I don't expect you to memorize all of them. I don't expect you to know their names. Actually, I don't know myself. That's why I turn around and read the slides. But what's important is to understand the different pieces of the puzzle and to identify within your organization who is responsible by what. Okay, we have big companies that actually have resources to invest in all of those, but we also have smaller companies that don't have those resources. If you cannot do all of them, you cannot do all of them, and that's okay. But you need to be aware of it and try to do it step by step, day by day, trying to improve here and there until you get to a point where you feel confident. And all of those different acronyms, they are under this CNAPP acronym, right? And the main thing here, Gartner brought that almost a year ago now, actually it was beginning of the year, that with the headwinds that companies are seeing and the economic crisis that we have, companies are shifting into a single solution that tackle all of those. In the past, you would have one company or one open source tool doing this, another enterprise company doing that, another enterprise company doing that, and that's just not cost effective. And by uniting all of those under a single enterprise vendor, it just makes it better for you in terms of cost, in terms of your teams learning faster. It is all under the same product, right? So that's kind of the trend of the industry right now. Good. So that was kind of my cloud part, which I think it's really important. Nowadays, most of us are running things on the cloud. We are using containers. We are using Kubernetes. We are using cloud one way or another. Now we go more into the software supply chain and what actually matters when you're creating and developing software. Good. So containers. Containers are key nowadays. Most of the things we do when developing or when deploying, we are using containers, right? And when I think about containers, I think about runtime. But to actually have a container running in production, we need an image. And to have the image for that container, we actually need a registry to pull that image from. And to have that registry, we actually need to have to publish that image to the registry, and we need to build that image at some point. And finally, to build the image, we need the source code with our application that we are going to run, plus the base image that's in there. And what I want to bring to your attention is all of those are attack vectors. Right? Things don't really change within software, right? Within the computer industry. Like MapReduce was a buzz like 15 years ago. It was invented back, or not invented, but published back in 1950. We're just repurposing things. So as we bring new stuff on, the paradigms, they change a little bit. but they're all based on the same stuff that we had way back. And here is no different. The thing is, we have more pieces in the puzzle, and with more pieces, more attack vectors. Good. So let's go into them. This is a simplified view of that one. It's actually from SLSA, SLSA. And basically we have the developer creates a source code, goes into the build, then into the package, and finally we're going to consume it. And of course, we have dependencies in there. And now we're going to go step by step into the different attack vectors that we have here. So one thing we could have is the submit unauthorized change to a repository, right? So a developer finished writing code, and it's sending that code to the repository. And what happened, for example, with Sushi Swap, is that a contractor with repository access actually pushed the malicious commit and started doing crypto mining and getting all the money to himself, right? So what is the problem here? Is that someone is pushing code that was probably not reviewed. Another problem that you can have here is that what are your settings within your repository? Are you doing the whole thing about, okay, nobody can commit to main? To commit to main, you need to actually go through a pull request. And to actually be able to merge that pull request, you need to have at least one approver. And that approver needs to be a code owner, someone we trust. Are those commits or those pull requests actually signed? Again, we're adding bureaucracy here, but we are protecting ourselves. And security is a little bit about that, right? It's boring to a degree that, okay, like, do we need really to do that? It's going to stop all the flow that we have here, and all we need is to just get this code out. But at the same time, yes, you want to get it there, but what is the exposure that you want to have? So at the end of the day, it's all about risk. How much risk are you willing to take? If you're a very small startup, probably attackers are not looking at you, or they don't care. But as you grow, you start like being interesting to them. Good. So the next one, compromise the source repo itself. So the attacker compromised a PHP self-hosted Git server and injected 2 malicious commits in there, right? So if someone steals a credential to a repository, what is it that they can actually do in there without other people noticing? How much they can change the configs in there. Like if I steal a credential from a developer, I can probably do something to the repository, but if I don't have admin or if I'm going through the least privilege idea, there's not much that I can do with those credentials in terms of changing the flow of we need a pull request, we need a reviewer, and we need an approval. On the build, going to the build, so from source to build, an attack modified the build infrastructure. So somehow they got access to the build infrastructure, probably leaked credentials here. And they use source files that were actually not matching. So the build infrastructure, instead of getting source files from here or only get from here, they were actually bringing source files from another source as well with malicious code in it. How can we audit that? How can we make sure that the build process is not getting stuff from other places? SolarWinds, that was a very famous one about 1-2 years ago. Basically, the build platform was compromised, and they injected malicious behavior during the build time, right? Another thing that people do during builds, especially with GitHub workflows and things like that, is basically they add a code to run crypto mining. So this is something you're probably not even going to see, but as GitHub is basically running your action, your workflow, there is also a crypto mining running there, basically sending money to the attacker. And it's just using resources that you were paying for. Dependencies, this is a big problem nowadays. We're talking a lot about SBOMs, like bill of materials, right? Especially with the US law that passed. Where is your dependencies coming from? Like, do you know in your code exactly what you are using? When you're bringing those dependencies in, are you sure that those are trusted dependencies? They have not been tampered by an attacker somehow. And the tampering can happen in many different ways. From build to actually packaging, attacker again used leaked credentials to upload a malicious artifact into JCS. This is basically the S3 from Google. So They got the credentials, they put something in there, and now if I basically have an S3 bucket with a malicious code, binary, whatever it is, now I can send emails to people basically saying, hi, I'm from Red Hat, or hi, I'm from Google, here's the link, and in the link it's going to be the name of your company, so it is a legit link from your company. What are you going to say, right? And probably people are going to click on it, at least some of them. People click on those links without even having a legit link. Imagine with a legit link in there. Finally, the package. As you have the package, that's where most people are going to actually get their packages from. So if you have popular repositories and attackers, they can actually put packages in there. They're malicious, and they can do that in many ways. Maybe they can just change the name. Typo squatting is a thing. It's when you have a string and you basically change a few characters. But our brains are just so smart that we barely see those characters change. So we actually think we are getting that link, and that's exactly what we want. Finally, yeah, similar thing here with the typo squatting as well. So malicious package, very similar name as the original, and that's what the consumer is consuming in there. So there are a lot of steps from getting your code into your consumers, your users, right? And all of those, they're gonna be exploited by attackers sooner or later. I gave you an example for each step here. Again, it's about risk. How much risk can you accept, and how much money do you have to invest money and time on tackling all of those? Good. Looking from another angle, so we have developers, we have the code, the repository, we have the build phase, we have the store, that's where we put our packages, and we have the runtime. So I bring the runtime now into the picture. As I said, all of those steps, they actually are attack vectors. On the source code, what you can do and what you should think about. So access to the repository is controlled appropriately. Again, I cannot emphasize enough list privilege. I am actually guilty. I was always like, come on, this is too boring. Just give me access to everything. And I come from a company where it was actually not that small, but we just had access to everything. We assumed everyone was just responsible enough to just have access to do things. And that's becoming more and more of a problem as we move to the cloud and as we expose ourselves in so many different steps. Credentials, leaked credentials, I think at least 3 or 4 of the examples I gave you came from there. Credentials can be leaked in many ways. They're leaked sometimes you're testing your code. To test, you just add the variable to the code itself, then you forget, then you push that code. That's one way of leaking credentials. You create your image, you forget the credentials within the image because you put it there just to test things. It goes to production, the attacker gets into that container because of a vulnerability. They get access to the credentials in there. Source code scanning, this is something you can do here, especially now with the AI, and there are a lot of talks here. Actually, there is a talk after mine about how to create software with AI in a secure way. And third-party dependencies, you want to be aware of which third-party dependencies you're using, right? Are they trusted? Are they actually investing in signing and offer you security enough? So you want to catch the malicious code before the build time. At build time, again, access to build framework, list privilege. I'm going to say that many, many times. Trusted base image. The image that you're using, is it a trusted base image? Is it signed, right? CI/CD malware injection, be aware of that. Sometimes leaked credentials allow attackers to inject malware within your CI/CD pipeline and use your build machines for crypto mining. Catch the malicious code before publish time. Image registry, again, access to the registry, list privilege. Registry misconfiguration, public, private. We had cases in the past where the registry had an image that had sensitive information in it. It was supposed to be private image. It was actually public. Registry break-in, again, credentials into it. You want to configure and secure the registry. Image vulnerability scanning, that's an important part of security. Not so hard to tackle. There are open source tools out there that help you with image scanning, and you can put them within your CI/CD pipeline. I'm going to emphasize that a lot, and I have slides for that. Minimal images. I gave you a few examples of how people just put something into an image, then that image goes to production, and that just makes the attacker life easier. Prioritization. Images and containers will have vulnerabilities. A host will have vulnerabilities. How do you prioritize that? You cannot tackle 2,000 vulnerabilities within your environment. You can tackle 100. So how do you go from 2,000 to 100? Prioritizing. How do you do that? Using runtime analysis, knowing exactly what can be exploited, what's loaded in runtime. And there are tools, open source and enterprise, that can help you with that. Image configuration, again, list privilege. Images out there, sometimes it's just, oh, it's easier. Just give admin, just give privilege. That's always the easiest path. Puts you at risk. Again, up to you to decide how much risk do you want to have. Minimize the image attack surface. Now we go into runtime. There are a lot of things at runtime that you need to be aware of. And I don't think I have time to talk in depth about all of them. So I'll try to summarize a few things here. Public malicious images, as I said, it can be with typo squatting or just inserting images into your registry, images that are not signed, and then you're using them in production, inserting malicious images into base image repositories, and you're not getting a trusted signed one because you just did not implement that. Container scaping, that's another vector. Vulnerable host, so the host is also vulnerable. You also need to patch the host that's running all those containers. Zero-day vulnerabilities, not much you can do there. They just happen. Like Log4j was a nightmare when they found the vulnerability. Social engineering, credentials, that's always an attack vector as well. Good. All right, so let's go into some more practical tips. Any questions so far? It's an hour-long talk, and be talking for an hour. I can definitely use a break. So if anyone has a question. All right, saving for the end, I'm sure. Let's go through some practical tips. So minimal images. I think that's low-hanging fruit that can cause a lot of trouble if you don't do. So make sure that when you're building your images, the base image that you're using, it's a minimalist one, at least when you go to production. So here's an example of a node with a 18 buster one, and you can see this is not the slim version. And those are the vulnerabilities that we have. We have 15 critical, 153 high, so on and so forth. The same image, but with a slim version of it. What is a slim version? It's a version without the packages, right? A lot of the packages that you're not actually using. It's a minimal version of the base image. And from there, you're going to say which packages do you actually want and do you actually need, and you're going to manually install them, of course not manually but with your Dockerfile, but you explicitly tell which ones are the packages that you need. So use a library of base images from a trusted source. That's another step. So not only make your image be minimal, but also get it from a trusted source, and ideally signing and checking for that. This is how bloated images look like, okay? And here I'm talking about 6.5. Some of those are actually 10 to 20 times difference. So if you look into an Alpine, that's 5.7 megabytes, a standard UBI, 37.5 megabytes. All the space here that you're seeing, the difference between this small cube and this one, that's just garbage. And worse, it's an attack vector, right? It's something that you don't need, that you don't want, but it's just in there. So attacker tools. So you might be thinking, oh, but my application is not using them, it's not loading into memory, so that's not a big problem. Yes and no, because maybe there was another vulnerability and the attacker got into that container, but within that container, the attacker is going to need tools to actually do something. Curl, wget to be able to download the scripts, VI, nano, to be able to change those scripts according to the environment to run the malicious code, APK, NPM, APT, yum, to download different packages, netcat that they might use, or any other package, tar, unzip, ifconfig, netcat. Like, those are tools that are not necessary for the attacker. Like, there are plenty of smart attackers out there that can do without those. But most of the attackers out there probably can't do anything without those. They're just going to find an easier target just around the corner, right? But you had those packages, so the attacker is just going to use all of them, and it's just going to keep poking and exploiting your system. So they love those tools, and by having a minimal image, you're just going to break their hearts and make their lives harder, right? Again, basically, avoiding theft or avoiding someone, a smuggler, to go attack you or rob your bicycle, it's basically the easiest lock to break, right? So just make sure yours is not the easiest lock to break. Okay, vulnerability management. So 87% of container images have high or critical vulnerability. But as I said, it's all about prioritizing. So critical or high vulnerabilities, but which ones actually have a fix available? Which ones are in use? And here you can use runtime information to filter that. And which ones are actually exploitable? And those are the ones you could actually focus on, right? So you have a small or big team, doesn't really matter. That's how you do your prioritization. You have an image here, CVEs. This package is OK. There's no CVE in there. It's a vulnerability. And here is it running. So at runtime, there is only one of those packages that's actually being used. So only this CVE here actually matter. Ideally, you're going to fix all of them. But first, you should tackle this one. So how do you go about it, right? This is the real risk. So you're going to ask yourself, do I have vulnerabilities in runtime? Are they in use? No, not a priority. Yes? Are they exploitable? No, not a priority. Yes? Do they have a fix? Yes. Then I send to fix immediately developers, ops. It depends on where it is on the chain. It doesn't have a fix. What can we do from the security side? What is the threat mitigation strategy that we are going to use here? As you build your images, it's going to make your life easier if you do the whole patching thing. For example, we're talking about minimal images, right? Imagine this is all within the bloated images. And then I find a vulnerability in package libcurl. Like, is it even within your image? Like, do you even know that information? However, if you go with a minimal one, and then you actually start adding the layers with each package that you need, by the time you figure out, oh, this library actually has a vulnerability. Where is this library within my environment? You can pinpoint, oh, it's just in the base image, or no, it's just in this layer. And then you can apply a patch and a fix just for that specific layer. It doesn't need to apply into the other layers. In this case, the layer is the base, which is actually going to regenerate everything. But in some cases, it's going to be like the latest layer, which actually is going to speed things up. Image signing and registry. So attackers, they have been putting more and more malicious images out there. Just like they put malicious websites, send malicious emails, now they're just putting malicious images. What is the problem with those images? Not much. They're still going to have your favorite OS. But along with the OS, they're going to have crypto mining just running in there that you don't know. Is that a big problem? Maybe not. They're not stealing sensitive data, but they are using your resources. You're paying for it. Or maybe they just have embedded secrets or backport so they can actually get into the container, and from there they get into your environment, right? So be aware of that. Make sure you use trusted images. How can you do that? You're a developer. You create an image, and you sign that image. You're basically saying, OK, this is the exact image that I created in there. Minimal one, okay? Don't leave packages and credentials in there that you're not using. They're great for development. Like, I need bloated images when I'm developing. I want to SSH to the container. I want to check things. Great. After you're done, when you move forward in the chain, make sure you have minimal ones. Containers should be immutable in production. People should not be doing SSH, netcat, ifconfig, whatever in production. So you sign, it goes to QA. QA makes sure that they actually getting the image that you signed is a trusted one. So they are testing exactly what they should. And then they are going to test it, they are going to give an OK, and this is going to be signed again. All right? And by the time the prod registry is actually getting or sending to the production cluster, so the production cluster is getting from the prod registry, there's actually another signature that's going to be in there. All right, you're a small startup. You're not going to do 3 steps. Again, it breaks the flow. It's overwhelming. Do at least one of them, okay? Do at least it here. Like, try to implement things bit by bit. Good? I think I'm just on time. I wanted 20 minutes for this last part. Any questions so far? No? Sure? All right. So, runtime security. Now I'm moving away from the whole cloud thing, talking about S3 buckets, identity. I'm moving away from the whole supply chain where you have the developer creating code, building it, and actually having the artifact, the package. Now we have implemented all the security layers, right? We cared about the CSPM, the cloud stuff. We cared about everything that I just talked, but we are still in production. We are running there. We are secure, but bad things can still happen, right? So how do you secure yourself when you implemented everything else, but a zero-day vulnerability just happened, like Log4j? So some suspicious activities that can happen in there. Again, a key was pushed into GitHub. You want to be alerted about it. Ideally, you want to block it, and there are ways to block it in tools, but at least you want to be alerted about it. Someone is starting a pod with a privileged container. This is basically a Kubernetes command to change the Kubernetes cluster, and that's what people usually do to either update the configuration or deploy new stuff. In this case, you might be deploying a new pod, and it's a privileged container in it. And you want to be alerted about that. Maybe that's a legit thing, but it's better to be alerted than not to know. Someone is logging into AWS within your organization, but they are not using MFA. That should be a red flag by now. Nowadays, you must have MFA to access AWS and others. You have a host. It's running a container, and someone is just running a sudo edit -s something in here. This is associated with a CVE. This is a potential for privilege escalation within your container. So basically, someone just trying to become root in that machine, and with root access, they just going to keep on poking. Those are the different things that you want to be alerted on, right? Going back to once upon a time, there was a perimeter, and now we are basically not blocking access anymore. But what we really need are good security cameras. You want a security camera looking into your Linux host and what's going on in there. You want a security camera looking into your Kubernetes cluster, letting you know that a privileged pod was deployed. You want a security camera looking to AWS CloudTrail logs, telling you that an admin was added to your account, or that someone just disabled MFA for a specific user, right? So if we're talking about Linux, security camera here should be looking at system calls. And that's one of the big changes that happen. I just said that software computing doesn't change that much. But one of the things that changed a lot is as we started moving from like hardware, like a single server, into VMs, into containers, all containers, they run within the same operating system, which means if a container is using the network, if a container is opening a file, it's all going through the same kernel. How do you access resources in a host? You go through the kernel with system calls. That's the way you do it. So it doesn't matter if you have 1 or 1,000 containers or 10,000 containers. To go to the network, to open files, all those containers, they go through the kernel. They go through system calls. So if you have a way to look into system calls, you have a lot of visibility into what is going on. Kubernetes, there are audit logs that you can look into. AWS, you have CloudTrail. GCP, you have the equivalent, right? And the camera here, you want to basically collect all those events. You want to run those events against a set of alerts that you have pre-configured, and you want to be alerted about the ones that actually matter. Another problem that we have nowadays is noise. It's basically people being flooded with too much information. So you need to have a good security camera to collect events, but you also need to have a good filter. And that's where Falco comes in. That's the open source project that I work with, right? So Falco is an open source runtime security solution for Kubernetes threat detection, but also for containers, hosts, and the cloud. It was created by Sysdig, the company that I work for, but it was then donated to CNCF. So it's now fully open source under CNCF. And it's currently at incubation level, but we're really close to graduation. That's kind of the latest state of maturity in your project within CNCF. It comes with more than 80 default rules. I just said that having the camera is not enough. You need to have a good filter, and that's what it comes with. So rules for crypto mining, executing a shell, mutating binaries, creating symbolic links, and so on. So Falco can ingest system calls, but can also ingest data from those other sources. And then it can send this data out to different outputs. One of them is Falco Sidekick, a younger brother. And Falco Sidekick can actually output to many other systems. There are a lot of integrations like Slack or Elasticsearch or PagerDuty if priority greater or equal to critical. Okay? How it works, I don't have a lot of time to go into the specifics here. The idea is, as you start Falco, it basically hooks into the kernel. It puts a eBPF probe in there. Not a lot of you know what eBPF is. eBPF is kernel instrumentation made simple. So it instruments the kernel to collect system calls. Those system calls are written to a ring buffer. A process on the user space is going to read this ring buffer, and it's basically going to go and parse those events and reach them and run them against a set of rules. And if an event matches a rule, boom, we have a suspicious activity. We send an alert to the output. Okay? It's a streaming tool. So very simple. You have an input, you do processing, which is filtering and enrichment. You have alerts that go out. All right? So now it's time for my demo. Let me just start the environment in here. It should take, hopefully, not long. I think it's there. Let me explain what I'm going to do. So the demo is about log4shell. Who here is familiar with exactly how log4shell exploits work? Good. All right, so I'm an attacker. I have a vulnerable server. What I'm going to do is I'm going to start a malicious server, right? This is, in my example, going to be a NLDAP server that's going to be serving Java class files, malicious one. As an attacker, I'm going to send a malicious request to the vulnerable server. The vulnerable server is a Spring Boot application, a Java application that has log4j. And every time a user tries to log into that application, it logs user X failed to log in. As simple as that. What is the problem? When it prints or user X, the X here, I can send a payload with the exploit. What is the exploit? By sending this JNDI here, it's basically going to interpret this, and it's going to see, oh, actually, I need to go into this address here and do whatever is in this URL. So it's going to send a request to my malicious LDAP server, because that's what I'm going to put in my payload, right? The malicious LDAP server is going to return the malicious Java class file. With the malicious Java class file here, it's going to execute that file. That file is going to have a command that's actually in the payload here that you cannot see. That command is a simple command. It's a netcat command. And that netcat is going to open a reverse shell to a netcat that I'm going to have here open. Okay? And I'm going to do step by step. Again, if I didn't have netcat here, that last step would fail. Right? Minimal images, easy, low-hanging fruit, very important. All right, let's go. this is my environment. Last year there. Good, bad. Can you read? Yeah, sure? All right. So I have one tab. This is me, not as an attacker. I'm a good guy now. I have my Kubernetes cluster. It has the account portal in it. This account portal, sorry, not get logs minus n account portal. Has a Spring Boot running. If I try to log in, here is my application. If I try to do something like admin, it's just going to print in there, hello world, my name, username, admin in there. Great. I'm an attacker. So what are the steps of the attack? Remember, I need an LDAP malicious server. So I'm starting my LDAP malicious server in there. It's running. I need a netcat listening at a specific port, in this case 9001, so I can get the request from the vulnerable server. And then, as an attacker 3, I need my payload, which I'm just going to put in here. So it failed. If I go back, boom, I'm in the container. And this is the exact container, the account portal container that I had before. So as an attacker, what can I do? I can start poking around. I can look for credentials. Oh, there's a credential in there. I'm not sure who put it in there, but it's in there. That's great. Oh, it's a Kubernetes credential, so maybe it's for the Kubernetes cluster. So I now maybe have access to the entire Kubernetes cluster. Let's take a look. I actually think my demo broke. Oh, it's back. Great. I tried it like just 10 minutes before, and kubectl somehow failed to install in the attacker machine, so I could actually not do this. But now it's back. Lovely. Oh, no, it's failing. Yeah. So what I would do originally, like yesterday I just did it, is I would basically set up my Kubernetes config file. I would use that file to get access, full access to the cluster. And with full access to the cluster, you could do anything. Thankfully, to my demo, I would not do many things besides just opening a shell. So I can actually continue the demo with that part broken. So going back to attacker 2, I'm still in the machine. So as an attacker, what I'm going to do is I'm going to download a binary for crypto mining. I'm going to extract that binary, and then I'm going to run my crypto mining in there, and then I can just live. In that case, I kill the crypto mining just because I don't want AWS coming back at me and shutting down my entire demo. And yeah, so that's what an attacker can do with a simple vulnerability in there. So let's see what Falco can actually do on the other side, right? That's what I'm working with. I still have 10 minutes. So what Falco was running full-time, and which is actually crazy, is it's working on this, but it's not working on the other one. Anyway, so Falco was running full-time, and I had Falco Sidekick as well, right? And Falco Sidekick was running outputting to Slack. And Falco Sidekick, besides outputting to Slack, has also the UI enabled. So I can do two things here. One thing that I can do is I can go to Slack, and you're just going to see that I have new messages. And one of those new messages is probably too small for you, but I'm not sure if I can make it bigger. Yeah, I can. It's a critical executing binary. So remember I said that I can output specific priorities. So in that case, I'm not getting notice and stuff. I'm just getting critical or above. So there was a critical activity within the cluster, within the host. That's a binary not part of the base image. And it's just in there. So with that, I go, OK, let's take a look into what actually happened. So I log into Falco Sidekick, and I have a summary of, OK, there were 5 things that happened. They are all syscall-based. 1 warning, 1 critical, 3 notice. I have tags related to different security frameworks. Can you just stop refreshing? And I have a summary of the different things that happen. So there was a redirect network connection, there was a drop and execute in the binary, and there was a netcat remote code execution in there. If I go to events, okay, I have it all here. So I can go all the way back and start looking into what happened. So first, there was a netcat remote code execution, and that was the exact, can this be bigger? The exact command that was executed within the reverse shell. So that was the step 4 of the thing. It was executed by the vulnerable server. I have the Kate spot in here information. I have the namespace. I should actually have the container image, but I was too lazy to fix that. Sorry for that. You have the connection information, but that is just a notice. Let me go straight to the critical part. So the critical is a drop and execute a new binary in container. How the hell do I know that a binary is a new binary in a container? So containers, they have an image that run on it, right? And what's great is that actually the OS has a flag associated with that. So any new binary that's added to a container, any file that you download, comes with a flag. That's the easy upper layer here. So if a file has that flag, I know it was added to the container after the container was running. That tells me that the container is not immutable anymore. Someone changed the container, and not only changed, they are actually executing that binary. And that is a red flag. All right? And you can see here that was an XM rig, and that's associated with crypto mining, so on and so forth. This is a subset of the rules that are actually enabled. I didn't enable all the rules that Falco has because some of them are too noisy, and we actually have a whole flow for you to enable and disable those. But yeah, so that's what I had on the demo. Any questions on the demo? As an attacker, if I could kill Falco? Yes, I could, but I would still have the remote netcat, right? And to kill Falco, I would need to have access to the cluster to do that. So yeah, I could steal credentials, and then I could actually connect to the cluster to kill Falco, but at that point, I already kind of gave myself somehow with the netcat, right? So yeah, of course, as an attacker, you're going to do a lot of things to bypass those detections, right? So it's kind of a cat and mouse thing. Could I kill a probe on that particular? You could, but then again, you need to have privileged access to the host because the kernel is running on the host, and that's where you need privilege to actually go and disable a probe, either a kernel module or a BPF probe. Yeah. All right, so some closing remarks. Software and cloud, they have a large attack surface. And yeah, things got more complicated. And that's just how it is. You might not be able to tackle them all. Choose the low-hanging fruits. Start with them. It's a process, all right? It's not from night to day. It's a marathon. Increased importance of least privileges, zero trust policies. Like, that's the thing. Minimal images, very low-hanging fruit. You saw, like, if I didn't have netcat, that wouldn't happen. I can find other ways if I'm a great attacker. Yes, I can. But it makes life harder. It's just like the lock in your door. The best teeth can probably break the lock in your door, but not the average one, right? Trusted images, like not so much of a high-hanging fruit in there, something that you could definitely do. Make sure you get third-party dependencies that are signed and that you use those. Actually, there is a very nice blog post from Falco. We just signed the entire project. Prioritize vulnerabilities if you can. That's a little bit of a high-hanging fruit because you need to implement stuff to actually be able to prioritize that, and then they are usually paid. Runtime security, that's important as well. A lot of people get stuck in this part because there is a lot to do, but installing Falco and just having, I didn't show how to run Falco, but it's one command, helm install Falco. Shift left is a team collaboration, okay? It's not about developer versus ops versus security folks. It's a group, it's a team thing. And security people should have patience and understand developers' problem, breaking the flow, like how you have other priorities, and worrying about those things just slow you down. That's true, but at the same time, you need to understand the risks. And you need to have an open conversation about what risks are you as a company willing to take, and agree on that, and then say, okay, so that's what we can implement. Those are the resources we have. Let's go do it. All right? Some references here. I'll share the slides later. And yeah, this is the Falco book. It's super cool. I thought I had deleted that slide because I didn't talk much about Falco. But it's for free, and it gives an overview of cloud as well. So if you want, just grab it. Thank you very much for coming. Thank you for having me here. And if you have any questions, I'm more than happy to take them. Yep, sure.